Okay, the quantum number gives us the address of the electron. That's what we've kind of been working toward this whole chapter, is up to this point. So think about your individual address. Think about your address. Okay, think about your address. How many parts does your address have to it?
3.
How many parts does your address have to it?
3.
The number of your house, the
Street,
street,
and
the city, and the state zip code, right? You've got the number, the street, right? 1000 Green Street, Atchison, Kansas 66002, right? 1, 2, 3, 4 parts to it. The quantum number is the same way. The quantum number, even though it says quantum number, the quantum number has 4 parts to it. Okay? The first part describes what we consider the main energy level. The main energy level. So the first part of our quantum number. I really want you to see this. Each atom has... No, I don't want you to even have that. I want it to say each quantum number has 4 parts. So I'm going to change that a little bit. Each quantum number has 4 parts. Okay, the first part tells us the energy level, or what shell level are we at. Okay, that's what that tells you. What shell level are we at? Okay, so if I know my electron is in a 1s orbital, that tells me it's in the first energy level. Okay. We're going to talk about each of these 4 parts more in depth, so you don't have to necessarily get them down now. But the second part is it tells us what shape orbital is that electron in. Is it in an S, a P, a D, or an F orbital? Right? There's only 4 options for that. S, P, D, or F. Agreed?
S, P, D.
Right. There's only 4 shapes of orbitals. So this is going to tell us what energy level or what shell it's in. And then it's going to tell us what shaped orbital it's in. Okay? That's the first 2 parts. We'll go in each of these parts more in depth. The third part of the quantum number tells us the orientation of the orbital. So it tells us for an s orbital, there's only one way it can orient itself around the nucleus. But the p orbitals, right, there's 3 different versions of the p orbitals. The d orbitals, there are 5 different versions of the d orbitals. And there are how many versions of the f orbitals? 7, right? There's 7 versions. And so what this tells us is basically what version of the orbital is it in. Okay, what version of the orbital. So we're looking at oxygen's last electron. It's going to tell us what shell is it in, what shape orbital is it found in, and then what version of that orbital is it in. The last thing it's going to tell us is what direction is it spinning. Remember when we did our orbital diagrams, we drew positive arrows and negative arrows? Those indicated to us the spin of our electron. And so this is going to tell us, is it the positively spinning electron or is it the negatively spinning electron in that orbital? Okay, so it's going to give us very, very specific details about where is that electron and which one is it in that orbital. Okay? So let's go a little bit more in depth on each of the 4 parts. The first part is called the principal quantum number. It's the one that describes to us the main energy level. It's kind of abbreviated or symbolized with a lowercase n. Okay? N tells us what energy level are we on, what shell are we on. Okay? The main energy level of the electron. Let's say that I'm looking at an electron, the last electron for sulfur, and it's in the 3p orbitals. 3p orbitals. What's my n value then? N would equal 3, right? It's telling me it's in the 3rd energy level. So it goes right there with my orbital name. Whatever that number is, that's what the first part of my quantum number would begin with that. Okay? That's like my house number.
3, P, 3, and then the rest.
Well, we would get something, there's going to be a number here that tells us it's in a p orbital. That's a good question. There's going to be a number there that tells us. So the quantum numbers has 4 parts, and they all have to be numbers. Good question. That's what we're going to do right now. Second part is called the angular momentum quantum number. That's not, you don't need to necessarily know the name. You just need to know that the second part tells us the shape of the orbital. Okay? It is symbolized by an L. You'll see me draw it as a cursive L so it doesn't look like a 1. Okay? It's symbolized by an L. And like I said before, it tells us the shape of the orbital. Okay? Values of L can be 0 through n minus 1. And so I'm going to show you kind of a different way to think about that here in this chart. Okay? If we know the electron is found in an s orbital, if we know the electron is found in an s orbital, then the L value for that part of the quantum number is 0. If we know that the electron is found in a p orbital, our value is 1, d is 2, and f is 3. So the L value can really only range from 0 to 3. So you need to go ahead and put this chart into your notes so that you know the second part of our quantum number is either S, P, D, or F, and then we know the number value that corresponds to that. So I want you to kind of look at an example. When I said L could be equal to 0 through n minus 1, let's take a look at if n equals 3, that means we're in the third energy level. L could be equal to 0, 1, or 2, depending on where the electron is. And so what this says is that means we have 3s, 3p, and 3d orbitals. Do we agree with that? Those are all just saying those are possibilities. And so we're going to be able to narrow down which one really needs to go in our quantum number based on the electron we're trying to find. But all it's saying is that these are the only possibilities we could have for the third energy level is 0, 1, or 2. Because it only goes, well, there's no 3f orbitals, right? So we couldn't put L equal to 3 there, right? Okay. For the first energy level, n equals 1, only s orbitals are possible. For n equals 2, we can have s and p. For n equals 3, we could have s, p, and d. And then for n equals 4, what could we have? S, P, D, and F. Right? We've already kind of talked about that, so I want to just look at that a little bit. You don't have to write this part down. This is something that we've talked about several times, so you don't need to have that exactly. Okay? The next part tells us what version of the orbital we're in. And so this is symbolized by an M. Okay, it tells us the orientation or the version of our orbital. Values of M are whole numbers including 0 from negative L to positive L. Okay, and so I'll show you what that looks like here. Okay. I know this seems confusing, but once we see it in our picture form, I think it'll come together. So the way we can connect quantum numbers is using our orbital notation when we draw things out into arrows. Okay, so I want to start with one right now. I want to look at the quantum number for oxygen. We're going to try to get the first 3 parts of the quantum number for the last electron placed in oxygen. Okay, so let's go ahead and look at oxygen here. Oxygen's last electron is what? 2, 1. Okay, let's say 2p4, right? 2p4. So the way I'm going to draw that out is using my orbital notation. I'm only going to draw out the 2p orbitals. Do you remember doing these with the lines?
1, 1, 1.
So 1, 2, 3, 4. Don't get ahead of me yet. I know where you're going, but don't get ahead of me just yet. That means we're looking at this electron. Do we agree? 2p4. We're looking at the last electron placed for oxygen. That's what we're looking at. So we know that in our quantum number, there's 4 parts, and they kind of get labeled like this. 1, 2, 3, 4, right? They're not really those values, but they have just a comma in between them. Okay? So the first part of our quantum number is the energy level. So it would be 2. The second part of the quantum number for this electron is the shape of the orbital, and it's in what shaped orbital? S, P, D, or F? It's in P, which means what number corresponds with P? 1. The third part of our quantum number tells us the orientation of the orbital, or what version of the p orbital. Okay? And so to find this, we look at these 3 versions. 1, 2, 3 versions of the p orbital. It's in this guy right here, right? And so the way we find the number that goes with that is we say, okay, if we are in the 2p orbitals, we said these values can range from negative L to positive L. Our L value is 1, and so we come down here and we label them negative 1, 0, 1. Right? Here's negative L to positive L, including 0.
So it would be
okay.
L.
So,
Positive L.
Well, this is a 1. Okay? So the number that corresponds with this version of the p orbital is negative 1. Okay, do we see how we're pinpointing that exact electron, and we're looking at, okay, we know it's second energy level, we know it's in a p orbital, which goes with number 1, and then we label our orbitals from negative 1 to positive 1. Okay, and we know we're looking at this electron, so we know it's in the negative 1 version of the orbital. Well, because we said we're specifically looking at the last electron that goes in oxygen. And that has to be this guy, because we went 1, 2, 3, 4.
So which number is significant then? Which one do I need to look at?
This,
Just the last one.
it'll tell you what electron we're looking for. We're looking for last electron in oxygen, and it's found on this version of the p orbital, which is the negative 1 version. Negative 1 is the third part of our quantum number, right up here. See?
Well, how big is the second one? Is that because...
That's because it's a p orbital, and so p goes with 1.
Okay, so you know how, P, it has the 3, and what if there was only 3 electrons, so it just go...
Then we'd be looking at this guy right here, and so that would be a 1 instead of a negative 1 for the third part.
1.
Right, right, exactly. We'll do lots of examples, but I want you to see where that's coming from. Okay, questions about how we label those orbitals? Okay. Last part here is the spin value, the spin. It only has 2 possibilities for the last one. Is it the positive spin or the negative spin? And they label them as positive 1/2 or negative 1/2. Okay, if it's the positively spinning electron, the last part of the quantum number is plus 1/2. If it's the negatively spinning electron, the last part of it is negative 1/2. Right, it's just 1/2, so it's either the positive or the negative. I don't know why it's 1/2. That has to do with things that are above my pay grade, right? It doesn't have any letter that corresponds with it. Sometimes it's given with an M, but I don't have to. You don't have to have that. Okay, I'm not going to watch that, but let's look at our oxygen example again. Let's continue our oxygen example. So if we're looking at oxygen, we said it was 2p4. So 1, 2, 3, 4. We know these are labeled negative 1, 0, and 1. So we're looking at that electron. So my quantum number is 2. 1 because it's a p. Negative 1 because there's where our electron is. And then what spin state do we have? Positive 1/2 or negative 1/2? Negative 1/2 because it's the second electron that went in. Right? And it's pointing downward. The downward tells us that's the negative spinning electron.
So whatever the last one is, whatever the last 2 electrons to go into the thing, that's what the last 2 are basically going to be. So if it's a negative 1, you have a negative 1.
Right. Okay, does that make sense? This is our completed quantum number. 1, 2, 3, 4 parts. Okay, there will be, find the quantum number for the last electron placed in copper. So copper is what? 3D.
Oh, okay. Wait, where? Oh. 3D9.
3D9. Okay, so that's what we're looking at. And so the easiest way to do it is to draw it out in orbital notation. We want to draw those arrows. We want to see it. So 3D has how many different versions?
9, 10.
There's 10 electrons, which means 5 versions of the 3D orbital. So draw it out. This is going to be so important and really helpful for us when we're looking at our orbital, when we're looking for our quantum number. Okay? So to put...
has how many 10?
D can hold 10, so there's 5 versions. So to put in 9 electrons, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And so what electron am I looking at?
That one right there, the last one that's...
That guy right there. Okay, does that make sense? We're looking for the last electron placed in copper.
It's 3, 2, 2.
Okay? Almost. Almost. Okay, we know our first part of our quantum number is going to be what?
3.
3, because it's in the 3rd energy level. We know it's in a d orbital, which means it corresponds to what value?
2.
Okay, look back at your table if you're not sure. A d orbital corresponds to 2, right? Go S, P, D, F, right? Think you can just count on your hand. S, P, D, F.
And then
Okay?
you have to label those.
So here we go. Now our orbitals get labeled.
-2.
Right, now they get labeled from -2 to +2. So -2, -1, 0, +1, +2.
No, yeah.
It would be 1, right? The 3rd part of our quantum number tells us it's in that version of the d orbital, which is a +1. Sorry, my thing is lagging a little bit. There we go. +1. And then is it the positive electron or the negative electron?
Negative. It's a negative.
Is it pointing upward or downward?
Down.
-1/2. Okay?
But I asked if the one I said if the one is in the positive, the other one would be positive too.
Nope, not always. If we were looking at this electron, we were looking at that guy, our spin would be positive. But since it's the last electron placed, it's pointing downward, and it would be a -1/2.
I don't understand any stuff we learned for like the last 5 minutes.
It'll go fast. Let's do lithium.
Too easy.
Okay, lithium
2.
is 2s1. We agree?
Yes.
2s1. So here's my orbital. Here's my 2s orbital. There's only 1 electron in it.
2,
So that means I'm looking at this guy. Okay? Here we go. The first part of my quantum number is 2. The s orbital tells me
0.
0.
And then
If I'm going to label this, it needs to be labeled from -0 to -0, right? It can just be -L to +L, right? That's just 0. So the only label that needs to go in there is a 0. So that means this value would be 0, and then is it +1/2?
too easy.
Okay? So this is the address of this individual electron.